We'll also stop it. Anyway, good morning. Welcome all of you for this some special talk actually. This is on Mossbauer effect, where the Mossbauer effect is taken as one of the landmark experiment in the 20th century, preferably after 1901. It gave a very good, remarkable results through the experiments what he set up in his laboratory. This unit, particularly the landmark experiments, whatever it is prescribed by the Bangalore University for physics students in second semester of fifth paper, is a very novel work. In the sense, we have to refer to the original papers published by the authors where the work was fetched a Nobel. In the sense, we may call them as the Nobel laureate, there is no doubt. But in the sense, instead of calling them as the Nobel laureate, the work has fetched the Nobel Prize. Even the work has gone to the extent in such a way that the scientific community throughout the world has accepted their work actually. Initially, it was not so, but always there will be some kind of an opposition, some kind of an what we can call disagreement for the works of the people, but still you can expect that what best one can have it actually. Here, Mossbauer effect is also known as the Rodolph Mossbauer, the full name of him actually, Rodolph Mossbauer, and he worked on the nuclear resonances, particularly how that the nuclear resonance can happen in the nuclei by the absorption of radiation. Maybe you can call it as a gamma radiation to a great extent, where there should not be a recoil for that. Recoilless nuclear resonance absorption. Mossbauer effect is also known as the recoilless nuclear resonance absorption. On the right side, you can see a person with in a picture in such a that name of Mossbauer, that is the Rudolf Mossbauer. His full name is Rudolf Ludwig Mossbauer. I mentioned on the left. He born on 31st January 1929 in Munich. The science, Munich is a German area before our Second World War to a great extent. The science, those countries and the entire world were under the issue of the threat of a war. It is a different story. We may be learning history, that's also a good sign for you actually. He was a German physicist and later got the Nobel. That is why he also called as the Nobel laureate. Remember the spelling for the Nobel as such. He was educated at about our schools in Munich passing, and they left the matriculation in 1948. 1929, he born, that is the beginning of the year, and in 1948, within about some 19 years, he completed the matriculation. Later, he worked 1 year as an optical assistant at Rodenstock Optical Firm in Munich, and for about hardly about a year as an assistant in an optical lab. Optical lab. Okay, optics is well known for studying the phenomenon of the radiations, particularly gamma and other phenomena. And later, he joined the U.S. Army and worked for some quite comfortable number of years. Okay, 1948 to 49. But with only 1 year actually. Then he started his graduation. In fact, they are calling it as the diploma course. They're calling it as the diploma course in the sense where we are calling it as Bachelor of Science degree about for 3 or 4 year program of that kind. He joined in 1949. It was offered at the Technical University Munich. Means even was a gracious enough actually. He was enough to join for the Munich Technical University in Munich actually. That is why it is called as like an engineering, like a diploma what we are calling actually. Okay, passed the preliminary diploma in about 1952 when he was hardly about 23-year guy. That is quite comfortable, almost an age of yours. But his diploma thesis, when he was doing the diploma, or polytechnic, what we call in Karnataka to a great extent, okay, when he was doing a diploma thesis in the laboratory of applied physics, a physicist with a special interest in the field of nuclear resonance fluorescence. And means how that the nucleus, how that radiation can go with the resonance phenomena, how it can have the phenomenon like a fluorescence, how how it behaves as a nuclear resonance when the radiation of incoming radiation and the outgoing radiation matches with either its frequency, preferably frequency. There should be a resonance in the frequency or wavelength should match. This I discussed in previous classes. What happens actually, see here, if you are sending a beam of any kind of radiation, particularly, and the incoming wavelength matches with the outgoing one, certainly there should be resonance. This term resonance is also known for sounds. Maybe, for example, if you take a tuning fork, if you hit the tuning fork with pad and try to vibrate it, of course, it vibrates, not try to vibrate, it vibrates. When it vibrates, it sends the mechanical energy to the neighborhood. And if you are having another tuning fork nearer to that, if it comes within the vicinity of, or maybe within the field of the vibration of the first tuning fork, certainly second tuning fork also starts vibrating. Maybe the air molecules will do the same case, but we may not be able to look or see that kind of a variations through naked eye with a good kind of a microscope or maybe kind of a recording system certainly we can have it. You might have heard in sound, particularly the rarefaction and compression of the waves, or maybe rarefaction and the elongation of the waves to a greater extent actually. Under pressure, certainly they will occupy the lesser pressure, and under greater pressure they will occupy the more pressure. If they vibrate with some frequency, that is the number of oscillations per second or maybe time we can call, if it matches certainly there should be resonance. Even you might have heard the word in such a way that particularly military personnel or any group of students or any mass in the sense mass of public actually, they are not allowed to march fast on bridges or flyovers they can call. Why? Because the frequency of vibration of the bridge, if it matches with the frequency of the footsteps or maybe running steps, either the way, certainly the bridge may go for collapse. In the sense, if the resonance happens, certainly there should be a collapse in the sense the amplitude of vibration will increase to the maximum level it was allowed and the structures may not sustain. But in other way, while getting a beautiful amplifications, if they are matching with the frequency, the resultant wave or resultant energy, resultant power, resultant spectra should be the maximum. Here, what the experiment was, he was trying to do was that when he was in diploma, he is trying to do with some nuclear resonance. Means nuclear resonance means that is the resonance of the two nuclei. Two nuclei of an atom, any kind of an atom, has to emit kind of a radiation. Those radiation should match. Then those if the radiation emitted by them is of same value, not similar one, same value, exact value of that kind. A should be A value actually. Whatever the number you are taking, the same number if it emits, certainly there should be a resonance for that. And they expected in the fluorescence. Earlier class, when in the last Saturday, I hope actually, when I was working within the classroom, in a regular classroom, we were discussing in such a way that if an atom receives the energy by any mode, either thermal energy or mechanical energy or electrical energy or electromagnetic energy, the atoms go for excitation from ground state to the higher energy states. Or in fact, the electron will absorb the energy. The absorbed electron is nothing but if it is associated with the atom, certainly atom is said to be in excited state. Or even the nucleus also can go for the excitation state to a great extent by the absorption of the energy. Particularly if it goes for the excited state, in the excited state it may not remain quite longer time. The maximum stability of an atom comes to be of the order of 10 to the power of minus 8 of a second, almost about roughly 10 nanoseconds or 0.01 microsecond. If it does not remain in the excited state, that is not a stable state or unstable state they can call, it has to come back to the ground state by attaining the stability, or to attain the stability it has to come back. Come back means even we are in physical term, we are speaking in such a way that the way we are narrating with the walking position or sleeping position of a human being, it comes back, going and coming back in the sense, it gets de-excited. Excited to the de-excited state, that is the neutral state, that is the most stable state. By the emission of the photons, that energy must be equal to the whatever the energy which is absorbed. Maybe sometimes it may be slightly less than the energy what it got absorbed actually. If it's slightly less, means certainly the wavelength of incoming radiation and the outgoing will mismatch. no synchronization, no resonance. But whenever it emits the radiation, that radiation, if it is a spontaneous, we are calling them as the fluorescence. Fluorescence is a phenomena for the emission of the light, for the emission of the any kind of a wavelength, then by the absorption of the incoming radiations, atoms and molecules will emit the radiation. If they absorb the energy and go to the excited state, they may not remain in the excited state for longer duration. Certainly, they have come back to the ground state. But thing is that if it remains relatively a quite longer duration, those atoms or molecules are said to be in metastable state that you might have witnessed in lasing activity or maybe the phenomena which causes the laser actually. Here what happens for the nuclear resonance is nothing but it is difficult. You can't excite the nucleus to a greater energy. Even though they are supplying the energy to a great extent, the atom may go to the excited state. If the energy supplied or absorbed is quite larger, it is related to technology, is still higher than the threshold value, atom will be ionized, means it loses its charges. It loses its electrons, maybe preferably the outermost electrons, then maybe the second innermost, second outermost, third outermost of that kind. It is always the atoms which are going for the ionization by losing the electrons should be from the higher orbits or outer orbits. Means to say, inner orbit like a K shell, for example, is to remove the electron in a K orbit is a very tough task. But there are possibilities in such a way that an electron may be absorbed by the nucleus from the innermost shell. That is the K shell. That effect is known as the Auger effect. They can call. If the innermost electron is absorbed by a nuclei, a proton gets converted into the neutral charge. Proton is a positive charge, and if it absorbs the electron, it becomes a neutral charge. So neutral charge. By the absorption of this, they can call it as an Auger effect. Nuclei go to the excited state. Nuclei go to the excited state. It may not remain there for quite longer time. Certainly, it has to come back to the lower energy states or maybe the ground state by the emission of the photons. This study was very difficult. That time, that is almost about 1950s. You imagine that actually 1950s, about 70 years back, 70, 75 years back almost actually. It was a tough task with the availability of the instrumentation, particularly scientific instrumentation and the technology. Okay, he was trying to do the experiments on nucleus. He was trying to do the experiments on a nucleus, particularly from the nuclear physics background. Okay, may not of nuclear physics background to a great extent. At the same time, he was acting acting in the sense working as a assistant lecturer at at its Institute of Mathematics and graduated in 1955. He was graduated actually in 1955, maybe at the age of almost 26 years actually. He then went to the Max Planck Institute for Medical Research in Heidelberg. In that institute, he was doing a course. In the course of which he carried out the first experimental observations of the phenomena of recoilless nuclear resonance absorption. In fact, the experiment name was he was working on an experiment to see the nuclear resonance by the absorption of the gamma rays. Instead, if we can call it as an electromagnetic radiation, if we are speaking for in terms of the atoms actually, but for the case with the what we can call nucleus is considered, they were working on the gamma rays preferably. Means assume that a gamma ray source is there, like cesium or cobalt or any kind of a source which emits the gamma radiation of relatively higher energy of the order of a few million electron volt to the giga electron volt also you can use. But in laboratory conditions, people are using this, that scientific community is using still earlier also and now also using the energies of the order of about a million electron volt. If you are going for a reactors particularly, any sample, that is the you can call it as a target or you can call it as a sample, you can call it as you can call it as an element matter of that conducting material can be exposed to the radiation coming from the nuclear reactors actually. There you can have the desired energies still of the order of a few tens of million electron volts. Where Baba Atomic Research Center, BRC, is having various centers in India, maybe Kalpakam, maybe Kaiga, or maybe accelerator centers, wherever actually, where the charged particles gets accelerated and they emit the energies. Those energies will be induced onto the material to see the phenomenon of or phenomenal changes in the material or to study the characteristic properties of the material, including structure of an atom and the structure of nuclei to a great extent actually. If this is a case, if this is a case, he was doing an experiment. He was doing an experiment for his graduation. It was graduation at Max Planck Institute on the nuclear phenomena, particularly. If the nucleus gets absorbed energy, if the nuclei interacts with the radiation, or the radiation, if you are allowing the radiation, or if you are bombarding the radiation to fall on a nuclei, we don't have an independent nucleus like a hydrogen nuclei or helium nuclei. You can't expect like that. You can't expect the gold nuclei of a gold. You can't expect the nuclei of an iron or the zinc, bismuth, whatever may be the elements which are available. Either maybe in the gaseous form, or maybe in the solid form, or maybe in the liquid form to a great extent. They can say that isolated nuclei, you may not expect it at all to a great extent. For example, if you are removing an electron from a hydrogen atom, it is lies with only the proton. That we can call it as an hydrogen nuclei, no doubt. Those acts like particles, hydrogen particles. That is, if you heat with the hydrogen, they carry some energy. And if you remove the electrons, two electrons should be there in helium atom. If you remove the two electrons, actually, there is a possibility for our mechanism to remove the electrons by the absorption of the energy. Certainly, it can call it as a doubly ionized. Ionized means single ionized means loss of one electron. Doubly ionized, loss of two electrons. Triple ionization, loss of three electrons. N times ionization, you can go with that at least. That leads with the so many electrons were knocked out or removed from an atom, and the atom is said to be in positive state. That is the positive ion or nucleus of that kind. If you remove the two electrons, there is no electron at all actually in helium atom, then it acts like an alpha particle. Alpha particle is doubly ionized helium atom, or they can call it as the nucleus of an helium. Nucleus of helium. If you are allowing them that, it comes with some job, it comes with some energy actually. Certainly it interacts with the any target elements. Like usually they can go with the zinc or maybe lead or maybe any kind of a material, maybe an iron, maybe a cobalt, maybe a copper of that kind actually. He was doing that experiment. It is a preamble actually, how it has to go actually. Okay. Then later, after he got the after his work was recognized by the scientific community and he received a Nobel Prize, then they named that work as the Mossbauer effect. Of course, you also work very seriously in your lab, current in your existing labs in physics department. Okay, and someday maybe after about few years, 10 years, 15 years, 20 years, 30 years of that kind, even for 100 years, people are receiving the Nobel Prize, or maybe the community, scientific community is recognizing their worth of the Nobel even at the age of 92, 95 actually, where the work was carried out when they were about 25 to 30, at most about 24 to 30 of that kind. This is a precious age for you actually, and it is a precious time for you. Means even after, not even actually, immediate after completion of your masters, if you work for any kind of a program or maybe a problem as a as a the doctoral student, PhD program, doctorate in philosophy they can call. Doctorate in philosophy they can call actually. Certainly those works can be recognized. I don't know. Listen, you mute yourself. Here, what happened actually? This he joined and he carried out the first experiment observation of the phenomenon called as nuclear resonance absorption. Okay, fine. Then when he was doing means what he carried out. They are saying that he had carried out the first experimental observation of the phenomenon of recoilless nuclear resonance absorption. Here, I will explain later in the sense after a few slides in such a way that how it has to go on actually. For example, if you are hitting any target, for example, with a powerful particle, the particle will bounce. That they can call it as a bouncing part. Sometimes what happens when it hits the target will also move in some direction, particle will also move some other direction. Maybe you might have experienced with the Raman effect in such a way that actually, along with the incoming radiation, the element, sorry, not the element, the atom will also move. That is the atom gets recalled. You might have well experienced with the example of, only the example of learning from the physics background in such a way that if a person from an NCC cadet or maybe a military person or any persons, they want to shoot a bullet from a gun, the bullet moves in the forward direction, goes in the direction where he or she holds the gun, and the force or the force at which it moves forward, there should be a backward force. That force is called the recoil force. Usually, not usually, the persons holding the gun must hold very tight against to their shoulders in such a way that the total mass, that is the mass of the gun plus mass of a human being together, a man holding actually should add together as the total mass. If they are not holding properly, certainly it hits the shoulder. There are not chances, evidences in such a way that so many NCC candidates have a wound on the shoulder when they were practicing for shooting. Okay, that is shooting of a bullet. Okay, here the phenomenon of recoilless of the nuclear resonance absorption. If you are allowing the radiation to pass, or if you are allowing the radiation to bombard the nucleus, the nuclei gets recoiled, means it absorbs energy and moves in some direction. Recoilless in the sense, without recoilless, how that resonance can happen? Means if you are having a two nuclei has to interact with the same amount of energy, exactly same amount of energy. There is no plus or minus value of that kind. In the sense, energy plus delta plus or minus energy should not be taken into consideration, because being an atom, that is a different story. But being for a nucleus, even small change in the energy will not cause the resonance. That is the beauty. If it happens with that, certainly we are getting the information about the nucleus in a greater deal. This person has worked out long back, and is gave a way, it gives a path, and it gives an understanding for the scientific community how the atom and other, sorry, how the nuclear structure is there, how that nucleus behaves when it is in resonance. This is the way. Since the institute, that is the Max Planck Institute, not being part of an university, means this Max Planck Institute was not an university where you will get an university, sorry, where you will join for PhD program only in university. Even earlier at that time, actually, universities are responsible for giving the awards, giving the degrees, like either graduation, you can call Bachelor of Science or Arts, Commerce, Engineering, or Master of Science, Master of Commerce, Master of Engineering, Master of Law, Master of Education, whatever you can call. In the sense, those degrees should not be awarded from the college, even though they may be having an autonomous. Autonomous is only for the academic freedom given actually. Why I am saying is that you should not learn only the way of addressing the Mossbauer effect. That is not a tough task. I am sure that all of you are learning very well actually. Here you should also understand that how the difficulties exist. Universities are responsible for providing the degrees. Indian Institute of Science is one of the academic institution actually. Okay, very ISRO, for example, it is not an institution. It is not an institution to award the degrees. It is not an institution to give the PhD program for you. Indian Institute of Astrophysics is not an institution to give the PhD program for you. The students who are working, or faculty who are working, or the person scientific community who are working in such type of an institutions, including TIFR Mumbai, Baba Atomic Research Center, National Physical Laboratories, National Chemical Laboratories, they are not the one actually. They have to register with some of the universities. Of course, nowadays, Indian Institute of Tropical, IITs, IIMs, IISc are taken as one of the academic institutions which can give the degrees of their own, including the university. You should feel more happy to be a part of Bangalore University, where you are studying your MSc in physics in a PG degree program of the university. Of course, even though you might have joined in some other colleges, those colleges have to depend on the university for the assessment and the evaluation and the award of the degree. Means to say we are having a good number of faculty members in our own department, along with the beautiful campus. That's a different story. Means why they are saying like that, because since the Max Planck Institute was not a university, he had no right to award the doctorate degree. In the sense, Mossbauer remained under the auspices of the Mayor Leibniz. You might have heard that Leibniz theorem actually of that kind, who then was his official supervisor for the thesis. Thesis is nothing but a detailed report submitted for the award of the degree of any of the course. Doesn't matter. Need not be of the PhD of that kind. When he passed his doctorate in philosophy exam in Munich in 1958. He joined in 55. In 3 years, he completed 58 with a thesis on, you read that German name in such a way with the translation of nuclear resonance fluorescence of gamma rays in iridium 191. You can iridium is an sample, 191 is the mass number actually, number of nucleons in an iridium. He worked on that during 58. Okay, that's why even though he started his experiment from 57 actually. He is best known for his 1957 discovery of the recall-less nuclear resonance fluorescence, for which he was awarded the Nobel Prize in 1961. This is a small fraction. The overlap is there. 1961. Within 3 years, he got the Nobel Prize. Means the work was recognized with scientific community. This effect, called the Mossbauer effect, is the basis of Mossbauer spectroscopy. You might have heard that different kind of spectroscopy should be there. See the person who has worked on it on the right top corner actually when he was very young. Okay. Good. You are referring to the quotes, you are referring to the sayings, you are referring to the idioms and phrases of several people, several known people, several notable people. We have to practice the words of the notable people, how they have succeeded in their life, how they have succeeded in their career, how they have succeeded in their, how they have succeeded in achieving the phenomena. No results, none of them have got in a single day or a single span of the time without undergoing a series of issues, series of the troubleshoots, series of deviations actually. What he gave, that is Rudolf Mossbauer 11, that was in 1958 actually, 58, he made an this was the quote made during the award of made by him during the award of the what we can call Nobel. He explained it. How he says is that he explained it. People are calling it as the Mossbauer's explained quote. They can call explain it. On the right bottom side, you can see. I don't know how far it is in faint because intentionally I took that one as the snapshot of that one. It is not an edited one actually. Okay, you don't try to edit the quotes either by the Gandhiji or maybe scientists or maybe by Ambedkar or maybe Vaswanda or maybe any of the philanthropists or educationists or scientists or the novelists or maybe motivators to a great extent. Actually, you have to quote them as such, but you try to understand in a different way or in the way you want actually by giving this explanation for it. How he made that checkmark is that explain it. The most important thing is that you are able to explain it. Why you are explaining it? Because you are capable of explaining it actually. How that capability will come, that is, this is an important thing actually. You are explaining the phenomena, you are describing the phenomena, you are responding to the query actually, you are answering in the question, you are answering to the questions in the classroom, you are answering to the question paper for the questions they have asked because you are capable of answering it. You will have the exams, no doubt. They you have to explain it eventually. You pass them. Means by giving the proper explanation, you pass them. You pass the query, you rise. You pass the query where you got the idea. You get your diploma degree, or maybe a master degree, or maybe a PhD degree. You think that's it. Getting a degree is not the end. Getting the award is not the end. Qualifying in the examination is not the end. No, the whole life itself is an exam, starting from birth, day one, till the last breath. Overtax is the examinations in the life. You will have to write the applications. Remember, applications is not for submitting to get an opportunity for the appointment or maybe getting an opportunity to join the institutions for the career or maybe PhD. Okay? You have to write the applications. Write applications for anything. You will have to discuss with the peers. We have to discuss with the peers means the experts in the field, the faculty in the field, teacher in the field, scientist in the field. Even you can think it out, a Google platform in the field, any kind of a searchable engines in that field, or maybe library in the field. Library in the sense, the books written which are available in the library. You have to discuss with the peers. So learn to explain it. You can try this by explaining to another student. How we can explain? We have to explain to somebody else. Whom? But you should be grateful. You should be grateful if a person listens to you. That's why all teaching faculty, whoever is very active, even though they are looking young, even though their age, you can't expect it at what their age is to be there. Okay, always looks like a charm and shining and bright. Compared to this comparison should not be done always actually, but as at the lighter note, you take it in such a way that compared to the staff who are working for the other sectors, the teaching fraternity, starting from school days to the high school, even colleges, even in universities, all teaching fraternity are active because they are interacting, they are explaining. Even doctors are also explaining to the patient, engineers are also explaining to the clients, the multiple MNC companies are also explaining to the clients for their application. You can train this by explaining it to the another student. I'm thankful for all of you. You are listening to me. I am trying to explain. Unless you listen, of course, whether you catch it up or not, that is a different way of the case. You try. My ambition is that still we are going in with a single slide from last 40 minutes. Intention is not to complete the syllabus. Intention is to make you to convince in such a way that if all the students got convinced by the concept what Mossbauer thought of it, even though from last 75 years, that will survive and serve the purpose of keeping this topic in the context of the syllabus, to learn more, to earn more, to do research and take the science to the higher levels in terms of the available scientific thoughts and the technology. You try to explain this to another student, maybe a colleague, doesn't matter, even to your neighbor, even if they are not available, explain it to your mother, for example. Certainly she will listen to you. Nobody in the universe will listen except your mother, because mother loves her children to a great extent. Whatever you say, that she will be proud to listen to you. Tell in your own language, whichever the language you are having practicing, or to your cat that is in foreign country, they are having such a fantasy to listen, or stand in front of a mirror and explain yourself that how the things are going on. If you are capable of explaining to it to the L of them, certainly you are understood this topic. If you are facing difficulty or anxiety or shy, or if you are getting somewhat not comfortableness in explaining the phenomena, then you have not understood the problem. This is a trial version of the Zoom you are using. In another few minutes, it may go off. Then within 5 minutes, you try to log in. It's far better. Still 5 minutes is there. Here, nuclear resonance fluorescence and absorption recall are the two topics of thoughts. What happens actually? Nuclear resonance fluorescence is comparable to widely known phenomena such as resonance in tuning fork, what I explained. And when one tuning fork is struck, it begins to vibrate with certain frequency. When a second tuning fork is struck close to the first one, it begins vibrating with the same frequency and is said to be resonant. Both are in resonance. A frequency vibration of first tuning fork and the second tuning fork. The frequency of the first tuning fork is having resonance with the frequency of the second tuning fork. Otherwise, the second tuning fork vibrates mainly because if it is having a resonance with the first one. This I explained. You use this same text for your reference. Fluorescence now is form of a resonance involving visible light, and when hits specific material, means that is the bombardment of light on a material, or if you are allowing the torch light on beam of light to the material onto the material, the atoms that makes up those materials, if it is of iron or maybe a copper or aluminum, any kind of a material, a solid material you can take, not of the liquid and gases to a great extent, may absorb electromagnetic energy. They are giving it to the entire spectra, but you restrict it to the anywhere and then re-emit it. See that here, the beauty is that actually it is not the scattering. They first absorb the energy and re-emit the energy back to its environment. That looks like a scattering for you. There is no doubt. During scattering, there may be a possibility of the resonance when the frequency or wavelength matches with the incoming radiation. The emitted energy has the same frequency as the original light as a result of the resonance within atoms of the material. If the atoms resonate with, if atoms vibrate with resonance, or if the atoms resonate, if they vibrate in the same frequency, or if the atoms vibrate, that will form a resonance when they are of in the same energy state. How that absorption and recall can go? After 1953, of course, when he was moved to the institute, he studied absorption of gamma ray. This is he in the sense Mossbauer we are referring, gamma rays in matter, in particular, study of nuclear resonance absorption. In his PhD work, or during his PhD work, Mossbauer discovered recoilless nuclear fluorescence of gamma rays in iridium 191. In the sense, whenever it heats, certainly there should be a recoil. He observed that recoilless nuclear fluorescence means if it is a recoilless means nucleus has not set back. The energy should be absorbed by some parent nuclei. There should be a mechanism to understand this. We will try to see that. Means how it was done? A radioactive isotope of platinum-like material he took. From then on, known as the Mossbauer effect. He discovered that at low temperatures, not at room temperature, a gamma emitter could be fixed within the crystal lattice, like NaCl crystal or maybe a KCl crystal. You have studied the crystal lattice and crystal structure in your condensed matter physics or solid state physics, of course, in modern physics too, to that extent, or even in chemistry. Material in such a way that it produces no recoil at all when it is released a gamma ray. Certainly, what happens before and after interactions, if you take, the energy supplied should match with the energy after the interactions, maybe kinetic or kinematic. If it is kinetic and kinematic type of an interactions will happen, certainly energy absorbed should be split into some part of the energy will go with the emitted radiation, some other part will go with the ejected particle, where that ejected particle carries a kinetic energy in the form of a recoil. It moves with some momentum. It has having some momentum. What they're expecting is that there should not be a recoil for that. Instead, recoil energy was absorbed by and also distributed throughout the total crystal lattice. See, recoil energy will be there, but think is that what happens? The atoms of the crystal lattice will absorb the recoil energy in which emitter was embedded. Huge of huge size of the crystals compared to the minute size of emitter atoms essentially wash out any recoil effect. Means if the size of the observer, if the size of the crystal, whatever you have taken, is if it is relatively larger dimension and certainly massive, for example, certainly it absorbs the energy to a great extent. Then there is no possibility of the atoms which can be washed out to the recoil effect and no recoil effect at all. Now it will log out. Just kindly log in after 5 minutes. By 11 o'clock, this is good enough. I will log in nominate. Thank you. I will take another 40 minutes. Kindly permit me. We will continue. We'll continue.